Let's talk files. So bench fitting is mostly done with files. I've got a small range and selection here. You've got plenty more than this available to you at See-Me. Got some weird and wonderful stuff here. These are little precision files, little needle files. It's actually a little set, so it comes apart, multiple ones on there, all different shapes and sizes. Good for little touch-ups, quite useful. You probably use some needle files when you were making your drill gauge, because then get into those really tight little nooks and crannies. Diamond file, so basically a piece of steel with diamond paste powder bonded to it. This particular one is actually used for sharpening knives and other devices, but still it's a file. It's an abrasive material, it removes metal, so it's a file. A rotary file, otherwise known as a burr, so you can mount that in ideally something called a die grinder. Can be used in a cordless drill if the need arises, and you can use that to remove quite significant amounts of materials. Quite a useful little tool. But we're talking about these things, hand files, so you've had some experience with them. You know that there's a wide range of different ones. I just wanted to go through a few points on these to make sure they're covered while you're looking at the Q&A. First and foremost is the health and safety aspect, and the eagle-eyed amongst you should have picked up one of the significant problems. This particular file here, big crack in the handle. I think I've got another one somewhere else, can't find it instantly. So we've got wooden handles on these. Wooden handles are great. I love a wooden handle because they're much more comfortable to hold. They do become less slippery even when they get dirty and embedded with oil and grease, etc. They still have the ability of a good grip and a good comfortable hold. These plastic handled ones here, if they get oily, they get slippery. They're a lot less comfortable to use, but they last very, very much longer because they're plastic. They don't crack, they don't split, which makes them sometimes a better option in terms of files. Couple more split ones here. Big split in this one split there, one split there. So what's the big deal with the split? Biggest problem with the split is as you use the file, the wood heats up. Moisture from perspiration on your hands gets in there, can cause this to swell, and it's not unknown for this crack to actually swell up and pinch down and grab hold of your skin, so you can't actually let the file go, and trust me, it really hurts. They're also prone to splintering from here, and obviously you don't want bits of wood embedded in your hand anymore than you want bits of file material. So any file that you see that's got a split in it, any file that you see appears damaged, any file that you see has embedded bits of metal in it, you would certainly be expected to return it to the stores to have a new handle fitted. In terms of fitment, you have to watch out for file handles. They push on. They push onto this tapered tang that we have here, and they're normally a tight fit. You have to normally knock them off. But over time, this little square hole that we've got formed in the end of the handle does start to, from constant side to side motions while you're filing, it gets bigger and bigger, and you can get to the point where the handle will slip off. Now a cursory glance at the end of the file will show you a nasty, unfinished, pointy, burred over piece of steel, which will very, very easily cut you and will cause you significant damage. You don't want to be anywhere near that. Worst case scenario is you're filing away, the handle comes off and your hand goes back in again, and before you know where you are, you've got some nasty injuries. So you need to make sure file handles are secure. It's not the end of the world if it's not. If you pick up a file and it comes off like this, put the handle back in place as far as you can. You grip the file, the metal part of the file, in your hand and just give it a sharp tap on the bench, and that will securely lock it in place. And you may have to do that several times throughout the day as you use the file, but that's perfectly normal. Okay, types of file that we've got. Well, I've got a small range, as I said, much bigger range at See-Me, but enough here for us to look at. Starting off here, we've got what's called a flat bastard file. Very aggressive tooth form on here. It's double cut, so what that means is you've got a line of grooves cut into it this way, and then they put a second line of grooves in this direction, which leads you to these quite pointed little teeth running all the way along the file body, pointing in that direction. So as you push the file forward, those little teeth start to bite off bits of metal and start to produce your finish. So that's a coarse file. It's a taper file, as opposed to this one here, which is a parallel file. It's square-ended. The advantage of the taper is you can, in some instances, get them into a very fine little slot and just use that slightly narrower end. We have a much smaller square file here. This is a fine file. I'll explain the chalk in a minute. This is the Swiss Army knife of files. This is, on one side, a reasonably coarse file. It's double cut, so we've got grooves going that way and we've got grooves going that way. So we've still got those pointed teeth. It's flat along here. It's got a tapered end, but the biggest bonus with this is on this side it's a half round. So here we have a radiused edge. This makes this the Swiss Army knife. You can file flat and you can file internal radiuses, you can open up holes, damage to holes, etc. with one of these. If you're doing any mobile work where you're taking tools around with you around the plant, always worth to have a half round with you. Get you out of a lot of trouble without needing to go back and get any extra tools. Similarly, for enlarging holes, cleaning up holes, etc., we have what's called a rat tail file. So anybody that's seen a rat will tell you that their tail does look quite similar to that, hence the name. It's a round file. They can come parallel. This one has a taper. It depends upon the style. These again come in anything from your very smooth, semi-smooth up to the bastard, really rough file that we've got here. This, one of my favourites, this is called a 3 square file. So in profile, I'll be able to see it is triangular. These are really, really useful files. These are very, very good for getting into square points that you need to open up. So we have this slot here that we need to remove some material, and let's say we need to remove some material from here because it's not quite deep enough. We've got two options with this. We can use a square shaped file. So we come in with our square shaped file here, and that could be a normal flat file or it could be a specifically square file. And you need to remember with these kind of files we have cutting teeth here and here and here and here. It cuts on all sides. Now if I start trying to remove material from down the bottom here, this file will do a very good job of that. But when I start getting right into this corner to really get right in here and remove some of this from out of the way here, because of the nature of our square file, it'll also cut here. And what will end up happening is you'll cut in through here and you'll cut along the bottom. Your end result will be something that looks more like that. Yes, you've got your extra depth that you wanted, but you've also got more width than you needed in the first place, and the job is now ruined. However, if we go in with our 3 square, a triangular file, which looks like that, and there's cutting teeth on all sides, what we can do with that is we can quite easily remove material from the bottom. You can see that it'll take that away from there, but because we've got this nice sharp point here, it won't remove any material from here. So the end result will be we'll have a nice flat bottom and the side wall will be exactly as it should be. That's why it's called a 3 square file rather than a triangular file. Its main role in life is actually to open up square holes that you need to file. This brings us rather neatly onto safe edges. So as we can see with the 3 square file, it kind of gives us a safe edge. There's an edge along here on this side that doesn't do any cutting when you're down in the bottom of that square or rectangular hole. Normal files sometimes have the same ability. So you've got cutting teeth on this face, you've got cutting teeth on this face. On this particular file, this coarse bastard file, we've also got a set of single cut teeth running along this side, and we've got the same running along this side. So this cuts on all sides. This file, however, has a set of single cut teeth running along this side, but this side has a safe edge. So there's no teeth cut on there. That means we can afford to get right tight up against a particular side without the fear of this bit making any cuts in the material. So depending on whereabouts you are, it's worth looking out to see if your file has a safe edge or not. Some do, some don't. Easiest way to do it is to just look at the files. Now, caring for your files is quite important. So you're going to be using quite a lot of files in the process of making your hacksaw, and one of the things that happens is you're going to get a lot of dirt building up in the file teeth, and that will actually be pilings or shavings from the material, bits of steel or aluminium that get embedded in the teeth, and once they get embedded in there, it will no longer be able to cut. The teeth can't see any material, so it won't be able to remove any. You need to make sure you always have one of these on hand when you're doing any filing operations. This is called a file card. It's kind of like a wire brush, but it's got some very stiff steel pins in there, and they're designed to fit in between the teeth. So you simply get your file, roughly estimate the angle that the cuts that you can see in the file are, place your file card on it, and just draw it backwards and forwards while you work your way along. And as you see, it does an effective job of cleaning all the debris out from your file teeth, which will allow you to carry on filing. If you're working with aluminium, it's got a high tendency to clog up with material because aluminium is very soft and quite sticky as well. So one of the ways we can overcome that a little bit is by using some of this French chalk. It's welder's chalk, it's available in the stores, and all we do is with the chalk, whilst actually making ourselves a nice point on the end of the chalk, and we just draw it down the file, and what we do in there is we're embedding chalk into the teeth, just like so. Interesting thing with this is it's very fine and it's actually quite lubricating, so you get nice smooth feeling and movement when you put a bit of chalk in there, so that assists with the filing process. And secondly, because there's chalk embedded in here, it's less likely that lumps of aluminium will become embedded, which means this will file probably for twice as long before I have to get the file card back out again and clean it out. It's an ongoing process. You're constantly putting more chalk in, but it can speed up the overall process by preventing it from clogging up. Let's look at filing sequences, and we're starting off with, okay, it's not a file, it's a saw, but actually it's very, very similar. It has the same style of teeth as your files do. They're hardened teeth. They're designed to cut metal in the same way as all the other files that you've been using are. And in terms of the process of removing material, this always comes first. So we have the hacksaw. So if there's a large piece of material that needs removing, for example the drill drift that you worked on, the most logical thing to do is do a nice cut and get rid of a big portion of the material from the blank as quickly as possible. So this files a very, very, very fine line, but it's able to do so for quite a depth and with reasonable control depending upon your skill. It's much, much faster than filing away all of the material in and of itself. Step one then is always this, and in terms of coarseness, the blade teeth apart, you could say this is the coarsest removal tool of all of the hand tools you're going to use, because it can take, well, it can take a metre of material off with a single cut. So therefore it is a very coarse kind of tool for removing material. Once we've got the bulk removed off, We're then going to be looking at finding our coarsest file. So here, and you can see how coarse that is. Big open tooth structures. Think of them as little tiny buckets scooping lumps of metal out as you push it forward. So the next process after bulk removal will be the coarse file. Once you've gone through the coarse filing, we're then going to bring in a slightly finer file. So you can see the difference between the two. These are a fraction of the size of the teeth that we've got here, so the amount of removal with this will be much lighter. But because it's not got those great big buckets scooping metal out, it doesn't leave great big gouges in there, which is what gives it its smooth finish. Once we've moved down from that one, we're going to finish off with a much finer file, something like this one, which has even finer teeth than the one that we've got here. So we've gone coarse, coarse, medium, fine, and that's the way we always work, going from a coarse cut to a fine cut. We can then look at finishing our work. We have things like Scotch-Brite, which is an abrasive material based on a plastic, very light removal rate, but still very useful. We can get some emery paper, and we can use that to remove more material and get it to a nice polished state. This comes in all sorts of grades through to, I think I've got a 1200 grade over there, which is very fine, almost as smooth as glass to touch, very good for polishing. Once you've gone to that stage, if you really need to get a very high-end finish, we're still working from coarse through to fine. We can start looking at things like this, and these are diamond based lapping compounds. And there's a coarse one, so this one, that'd be 7 micron size, down to 5 micron to 1.5 micron, down to the finest one here, which is a 0.5 micron diamond lapping paste. This is the sort of thing that you can use for polishing glass, and you'll see no scratches whatsoever. We can use these for lapping, which is the process that your Q&A talks about. It's a very simple procedure. All we would have to do if we want to lap this block, let's say, to this bench, all I'd need to do would be apply a little bit of paste to one of the surfaces and introduce one on top of the other, and move them backwards and forwards. What will happen is the abrasive between the two will remove all the high spots from the bench and from the block that we're trying to get down to size, and that will give us a lapped smooth finish at the end. So just going to finish up with filing techniques. Slightly unusual setup here, not the kind of setup that you're going to have. My vise is a bit too gloomy over in the corner where I've got my vise, so I'll stick to it on the bench. The type of filing you've done so far has been what we would call conventional filing. So in that instance, your file is approaching the work. You've got it one hand on the handle to guide and provide the energy. Normally one hand, or at least a thumb and forefinger, on the front to give some control and some stability. And as we're moving forward with the filing stroke, we're applying some downward pressure. What we should be doing is, as we finished and we're on the back stroke, we should then be releasing that pressure so the file comes up in a real ideal world without any contact at all. At the very least, what's normal is it'll be just the weight of the file dragging it back, and then we can go again, and we continue doing that until we've removed the material that we want. That's conventional filing. You can do it square on. Very often a more convenient way, if we've got a larger surface, is to actually diagonally brush the file across as we go, and that will give you a bit faster removal rate. But remember, we've got all those little teeth gouging their way at the material. You can see I've already scratched up this component quite quickly. And when we get to the final finish, we want to be able to make that a little bit smoother. Even if we're going to continue on to use abrasive techniques to get that as smooth and as polished as we possibly can, we still want to remove some of those scratches that we've got in there. Which brings us to the second technique with a file, draw filing. So before we've moved, as you can see, across at right angles to the work, this time with draw filing, I'm going to hold the file squarely in both hands, and rather than going this way, I'm going to move the file backwards and forwards at right angles to the actual length of the file. Now what's happening is these lines that we've got cut in to make the teeth, in this direction they're almost at right angles to the material. The teeth are fully exposed and they're able to take big cuts. Here, because we have these angled lines here, if you look as I draw them across the material in a draw file methodology, the actual face of those teeth are getting a lot less exposure. So rather than taking a big heavy chopping cut here, we're doing more of a light shaving cut in this method, and what that actually does is it produces much smaller, much finer grooves in the material, which makes it smoother and approaching a better polish. That's draw filing. It's a useful technique, and it's one that you need to get a good understanding of. There's another technique that we can use on this to find out if we've got any high spots. So high spots might stick up, might not be obvious when you're using the normal filing techniques, particularly if you have a tendency to rock a little bit or to angle over to one side or another. So to check this for high spots, all I would do is put my file directly onto it, and whilst applying even pressure, just slide it backwards and forwards. And what that will do is, if we've got any high spots, which doesn't seem to be actually on this because it's a nice machine piece of cast iron, but any high spots will show up as little shiny areas where the file has just removed material from the top of those high spots. So that's a good way to find if there's any bits that you're missing, any high spots on there that need reducing, just by holding the file on there, not lifting it up at all. I'm not putting too much weight on, but I'm just drawing it backwards and forwards, and in the file teeth just remove anything from the high spots. Well, there might be a little one there, little area just starting to shine up, and in these corners it's just starting to shine up as well, which we kind of would have expected on there. So yeah, good way of finding a high spot by using that technique. One of the other tasks that you've got to do is produce a radius on there. Now I know you've been through the process in the workshop. Just to clarify, because it is kind of counterintuitive the way we're going to do it. So what we're going to do to produce a radius, you need to start with your file, square onto the work, and as you push the file forwards, you need to drop the back end of the file, lift up the front end of the file, and keep going until ideally when you reach the end of the file, your file should be upright. And that will give you a smooth radius between this flat face and this flat face. In practice it's very difficult to get that last bit because you end up hitting the file handle up against the body of the material, but that's close enough to get a decent radius smoothed into there, even if it does look a little bit counterintuitive. You'd think you'd probably go the different way, but you're actually sweeping it in opposition to the radius you want to produce. So you end up, if you like, with two semicircles crossing over each other. Soft materials, probably my least favourite to file. You've got to do a load of it. You've got to produce an aluminium handle for your hacksaw as your assessment piece. So as we've said already, aluminium is really, really soft. Soft materials don't like fine files because, as we said before, the gaps in these fine files are really close together and they clog up really, really quickly. So rule of thumb, always soft materials, at least for the bulk of your removal rate, what you want is a nice, coarse, aggressive toothful. This will take big bites of the aluminium, but the gaps between the teeth are big enough to allow that aluminium to fall back out again. And normally, as you do the forward stroke, they will fill up. As you come back lightly with just the weight of the file on it, they'll normally get pinged out and it'll leave your file nice and clean. You can still do a draw file with it, which will polish it down a little bit, get rid of some of the deepest scratches, and obviously you can finish it with a fine file, but you want to be doing the least amount of fine filing as is physically possible. Your best bet for bulk removing aluminium, once you've hacksawed it, something like this, which is a mill form file. Called that because it's got these big sweeping teeth which look like they've been produced on a milling machine. This is very, very aggressive, as you can see. Big open, 4 or 5 mil spacing between each teeth. The nice curve means that it's a nice sweeping action that cuts material really, really well. And you'll have to go some to clog one of these up. This will remove aluminium at a very, very high rate. Also good for wood. Works very effective on wood, in actual fact. So any soft material really, even some plastics if they're big enough, can be filed using this kind of mill form file quite effectively. Let's talk about sawing your aluminium. So aluminium, as we've already decided, is soft. We know that. We could probably cut that with a knife quite easily without doing too much damage to the knife. We also know from looking at files that to file aluminium you need really coarse, big, open tooth. And the same applies when we're looking at hacksaws. We've got a selection of hacksaw blades here. I've got 18 TPI, 24 and 32 TPI. TPI is teeth per inch. It's an old-fashioned measurement. It's still the industry standard, even though it's an imperial measurement. So the 18 TPI you can probably see just by looking at it. Let's move the alley out of the way. Might give you a clearer indication. 18 TPI, quite big teeth, lots of space in between them. 24, very much tighter packed in there. 32, you'll be lucky if you can see those on the camera. They're tiny and they're really, really close together. So for cutting aluminium, it's always going to be the coarse blade, 18 TPI. This is definitely the best type of blade to be using. The big spaces mean the aluminium won't clog it up and it will be able to continue cutting. If you try and use either the 24 or the 32 when cutting something like aluminium, they're just going to clog up instantly and it will just not become effective cutting. You'll just be using huge amounts of energy pushing an aluminium clogged blade to a piece of aluminium without any cutting whatsoever. However, there's some other considerations that you need to bear in mind. If we go the opposite way and we have a piece of hardened steel, piece of stainless steel perhaps, piece of tool steel for example, something very, very hard, if we try and cut it with these big open teeth, because they are big open teeth, because they are so well spaced apart, when they come into contact with a piece of material like this chalk for example, you can see there's only very few teeth that actually at any one point make contact with the material. So all of that really heavy cutting load of a hardened piece of steel is going to be spread out across maybe 7-8 teeth, which means the loading on those individual teeth is going to be enormous. If we however put a 24 TPI tooth on there, and they're too fine for you to see, but we've probably got, because they're so much tighter together, you've probably got at least 50% more teeth in contact at any one given time, which means that that load of that heavy material is distributed over more teeth, and the teeth are under less load when cutting. They will last longer. We can go right up to 32 TPI, and we've got lots and lots of teeth in contact with that there, so the load is spread out nice and evenly. Another consideration when you're selecting hacksaw blades is the thickness of the material that you are going to cut. If, for example, you've made a test hinge for your toolbox in sheet metal, and you decide you need to trim it down here, which tooth blade would you use? Well, this we know is 1mm thickness material. If we try the 18 TPI and we set that up in our saw blade holder and we try and cut that, we can pull it, but we can't easily push it because the metal is nearly as fine as the gap between the teeth. So there's virtually no amount of force that will push that forward. Also, every time that's cutting, one single tooth is experiencing all of the load to try and make it cut, and you're very, very quickly going to break the teeth on that, and that blade will be no good. Might try the 24 TPI, which is a standard sort of fine material cutting blade, and it's still a little bit difficult because that fine material is still getting clogged in between each tooth, but with a little bit of angling down you can actually get it to start to cut. It's not so easy, but it will. Ultimately, something that thin I would recommend a 32. So 32, now as we push that across, there are at least 3 or 4 teeth actually making contact with that 1mm piece of material. So rather than acting a bit like a ratchet and getting stuck, it's able to move quite freely across and cut without putting too much load on the teeth. So practical upshot, files and hacksaw blades, the same applies. Soft material need big teeth with big gaps in between them. Hard materials need small teeth with small gaps in between them so that they don't clog up, and so the loading per tooth is much less.